What's up, dear students, and welcome back to a new lesson. In this lesson, we're going to be talking about objects that are thrown at an angle. Okay, so in the previous video, we talked about objects that are thrown off an inclined place. Okay, we said that Vy is 0, okay, when the object is thrown. Okay, of course, Vy initial. Vx was always constant throughout the process. Okay, it was only Vy that was changing. Now let's say this time, guys, we have, let's say, x component and y component. This is x, this is y. This time we have an object that is thrown at an angle. Okay, so let's say this is v initial of the object, and we have a ball. Okay, so the ball reaches here, then it reaches maximum distance, and it reaches here, and then it lands on the ground. Now we said, guys, that vx, which is the horizontal motion of velocity of the object, is always constant. Okay, so it's constant, it never changes. The only thing that is changing is the what we call vertical velocity of the object. Now at the maximum distance here, okay, Vy is equal to 0. Be careful. Okay, we call this delta y max. At maximum height, guys, let's say that the horizontal displacement is equal to 300. At maximum height, it is equal to 150 meter. And the other side too, also 150 meter. Okay. Now, if delta t is equal to 25 seconds, or let's say, 25 seconds, at maximum height, delta t is equal to 12.5 seconds. Okay, be careful. So it's half when it's on the when the object is reaching maximum height. Okay, now if you draw this, guys, of course you're going to have two components. Be careful. So I'm going to take only this component. Okay, but just be careful. Here delta y is going to be like this, but here delta y is going to be like this. Okay, just a note. Now I'm going to take this and draw this again. Let's say we have a vector like this. Okay, x component and y component, and the vector here is like that. Okay, this is, let's say, v initial. Okay, the angle, let's say, is made with the x-axis theta. Okay, now this vector, guys, I only took this vector. Be careful. Okay, this vector is going to be analyzed into two components. So I have x component, I'm going to call this vx initial, and then I have this one vy initial, which is going to be like that. Be careful. Okay, now remember, guys, that we said if the angle is made with the x-axis, cosine goes with the x-axis. So vx initial is equal to vi, this one, multiplied by cosine theta. Okay, now vy initial is going to be what? Vy initial is equal to sine theta. Be careful, but first this one, so v initial multiplied by sine theta. Okay, I think you remember this, that you have studied this in vector analysis. Okay, now, guys, remember that in the previous video that we said if you have the motion of an object, a projectile motion of an object, we were saying that vx initial was equal to delta x divided by delta t. Okay, and we said that, but this time, okay, let's do this directly. This time, guys, look, vx initial is equal to vi cosine theta. So my next equation is going to be what? Instead of writing vx initial, I'm going to write v initial cosine theta. Okay, which is equal to delta x divided by delta t. Then we had this equation v final, which was equal to v initial plus g delta t. Okay, instead of writing v initial, guys, okay, but be careful, this is y. Okay, this is also y. Instead of writing vy initial, okay, I'm gonna write v initial sine theta. So my next equation is what? V final is equal to v initial sine theta plus g delta t. Okay, now we also had this equation vy final squared is equal to y initial squared plus 2g delta y. Okay, but instead of writing vy initial, I'm going to write what? I'm going to write vi sine theta, v initial sine theta. So vy final squared is equal to vy initial squared, so v initial sine theta, this one is going to be squared, and then sine theta, all of it squared, be careful, plus 2g delta y. Okay, guys, this is for finding maximum height. If the question asks for maximum height, we're going to use this equation. We had also one last equation, which was what? V initial delta t plus 1 over 2g delta t squared. Okay, so instead of writing vy initial, I'm going to write what? I'm going to write delta y is equal to v initial sine theta, of course multiplied by delta t, plus 1 over 2g delta t squared. And we cancelled one equation, because which was this one, delta y is equal to 1 over 2 v initial plus v final delta t. We cancelled this because it doesn't have gravity in it. Okay, the other ones, all of them have it. Okay, now guys, this one is for what? Just a simple note, this one is for x component, be careful. And these equations, all of these, okay, these are for y component, be careful. Now, these are the equations we're going to use. Basically, this is what I've explained now. Practice or sample problem 2 is solved. I want to make the video shorter, so I'm not going to solve this. I'm going to solve some questions here, then I'm going to leave the rest for you. Okay. Question 1, guys, it says, in a scene in an action movie, a stuntman jumps from the top of one building to the top of another building, which is 4 meters away. So you have 2 buildings basically. Okay. The distance between them, which is delta x, is equal to 4 meters. Okay. After a running start, he leaps at a velocity of 5 meters per second. So v initial is equal to 5 meters per second. So this guy, which is over here, is trying to jump onto this building. Okay. And theta is equal to 15 degrees. I don't know why I said Newton. Okay. 5 meters per second. With respect to the flat roof, will he make it to the other roof, which is 2.5 meters shorter? So you see that this one here is 2.5 meters shorter than this one. Okay, so he says, will he make the jump? Okay, in order to find if he makes the jump or not, I need to find the height of the other building. The only information that he has given me about this is that building is 2.5 meters shorter than the other building. Okay, so it doesn't give me the height. Okay, so this one is delta y for that building, be careful. Oh, it's the difference of the height, which is 2.5 meter. Basha. So what am I going to do? I'm going to first find delta t and then find delta y. Okay, so let's use a different color. Remember, for finding delta t, we only have this equation, which is the horizontal one. Delta v initial cosine theta is equal to delta x divided by delta t. Okay, now when I said that we only have this equation for finding delta t, I mean when you see that when you have the givens written, of course, the only equation that works for finding delta t is this one. Okay, the others, you have missing variables, you have missing things too, so you cannot use it. The only equation is this one. I have everything and I can find delta t. Okay, so delta t is equal to delta x divided by v initial cosine theta. Okay, delta x is 4 meters. Okay, v initial is 5 meters multiplied by cosine of what? Of 15. Okay, delta t is equal to 0.83 seconds. I think you get 0.828 seconds. This approximately becomes 0.83 seconds. Okay, now let's find delta y. Okay, so which equation I'm going to use for delta y? Of course, this one. Delta y, because the question doesn't say find the maximum height. Okay, so delta y is equal to v initial sine theta delta t plus 1 over 2 g delta t squared. Okay, I have v initial, which is 5 meters. I have sine theta. Oh, I have theta, which is equal to 15, of course. I found delta t, which is 0.83 plus 1 over 2, but be careful, this is negative 9.81. Okay, so multiplied by negative 9.81, multiplied by what? Multiplied by 0.83 squared. So if you calculate this, you're gonna get negative 2.3 meters. Be careful. So is he going to make the jump? Of course he's going to make the jump. So how do I know? Let's what we call add the two heights that I have. So this one is the height of the small building. The difference between them was equal to what? So let's say this is 1 and this is 2, was equal to negative 2.5. If you add these two together, you're gonna get a number which is bigger than 4. Okay, so this is 4.8 meters. Negative 4.8 meters. Is he going to make the jump? Of course. Okay. Question 2, this is for you. Question 3, it says a baseball is thrown at an angle of 25. So theta is equal to 25 degrees to the ground at a speed of 23 meter per second. V initial is equal to 23 meter per second. If the ball was caught 42 meters from the thrower, okay, so this is delta x, which is equal to 42 meters. How long was it in the air? So delta t is equal to what? How high did the ball travel before being caught? So delta y is equal to what? Okay, delta y is equal to what? Now, for finding delta t, guys, okay, I'm gonna say what? Again, the same equation I used. So delta t is equal to delta x divided by v initial cosine theta. I have delta x, which is 42. I have v initial, which is 23, multiplied by cosine of 25. You're gonna get 2 seconds. Okay, and for finding delta y, what am I gonna use? I'm gonna use this equation. Be careful. The question says, how high did the ball travel before being caught? Be careful. It says how high. Okay, so it needs the maximum height. Be careful. Okay, now a simple note, and I talked about this too. I said that at maximum height, Vy final is equal to 0 meter per second. Be careful. Okay, now I said which equation you're going to use for finding the maximum distance. Be careful. Or maximum height, sorry, this one. Be careful. Okay, v final squared. So I'm going to use this equation. V final squared is equal to v initial squared multiplied by sine theta all squared plus 2g delta y. Okay, so this is the equation I'm going to be using. So this one is max. Okay, and rearrange the equation. I need to find this delta y, so move this to the other side. Okay, so it's going to be v final squared minus v initial squared multiplied by sine theta all squared is equal to 2g delta y max. Okay, I need to find delta y, so this one divided by 2g, this one also divided by 2g. So these two cancel. I have this one, delta y maximum is equal to, we already know that v final is 0, so it's going to be what? It's going to be negative v initial squared multiplied by sine theta squared divided by 2g, which is 2 multiplied by gravity. Okay, now we have what? We have v initial, which is equal to 23. Okay, so negative 23 squared multiplied by sine of what angle? Of 25, and then all of it squared, divided by what? Be careful, we have 2 multiplied by negative 9.81. Okay, so if you calculate this, you're gonna get 4.8. So delta y max was equal to 4.8 meters, or negative, if you want to be specific, but because the two negatives cancel here, so it's going to be 4.8 meters. Okay, so this is the maximum height. Now, question 4 and 5, these are for you too. So I'm going to move on to section review. It says, which of the following exhibit parabolic motion? Okay, a flat rock skipping across the surface of a lake. So if you have done this, okay, on a river, that for example you throw a stone over a river and you see that the stone is what? Is skipping, okay, or it's bouncing off the surface of the water. So do I have projectile motion? Yes. A 3-point shot in a basketball, of course, when you throw the basketball, you have a projectile motion. The space shuttle while orbiting around the Earth? No. A ball bouncing across a room? Yes. A life preserver dropped from a stationary helicopter? No. Okay, so this is not projectile motion, be careful. Question 2, it says, during a thunderstorm tornado, a tornado lifts a car to the height of 125 meters. So delta y is equal to 125 meters. Increasing in strength, the tornado flings the car horizontally with a speed of 90 meters per second. So V initial is equal to 90 meters per second. How long does the car take to reach the ground? So delta t is equal to what? How far horizontally does the car travel before hitting the ground? So it says what? Delta x is equal to what? Delta x is equal to what? So I have delta y, which is negative 125. Now for finding, guys, this is like that, be careful, the one that we studied. You have this, for example, and the object is going down like this, be careful. So for finding delta t, I'm going to use this equation. Delta y is equal to negative 1 over 2 g delta t squared. Okay, now delta y is equal to 125, and then I have what? I have negative 1.2 multiplied by 9.81. 9.81. This negative comes from the 9.81. I already applied that. Delta t squared. Okay, I need to find this one. Now let's calculate this. 0.5 multiplied by 9.81. I get 4.9. So I get 4.9, of course, negative delta t squared, which is equal to negative 125. Divide this by negative 4.9. Divide the other side too by negative 4.9. These two cancel. Delta t squared is equal to square root of negative 100, before that, negative 125 divided by negative 4.9. Okay, so 125 divided by 4.9, we get 25.5. So the two negatives cancel. Delta t squared is equal to 25.5. Then delta t is equal to what? Is equal to square root of 25.5. So square root of 25.5, we get 5.049 seconds, or 5.05 seconds. So this is the time that it takes for the car to drop the ground. Okay, now what about the how far horizontally does the car travel before hitting the ground? So what do I need to find here? I need to find the delta x. So I know that delta x is equal to, sorry, before that, I know that v I know that Vx initial is equal to delta x divided by delta t. I need to find this delta x. So delta x is equal to V initial delta t. Okay, Vx initial delta t. V initial is equal to 90. Delta t was equal to 5.05. I found that. If you calculate that, you're going to get 454 meters. Okay, let's make sure. So 90 multiplied by 5.05. Yeah, 454.5 meters. Okay, so this is the horizontal distance that the car travels. A rescue plane belonging to the Red Crescent Society of Kurdistan drops a package of emergency rations to a stranded party of explorers, as illustrated in the figure. The plane is traveling horizontally at 30 meters per second. So I know that, be careful, this is horizontal velocity, so Vx initial is equal to 30 meters per second. At a height, so delta y is equal to negative 200 meters. It says what? It says delta x is equal to what? So to find delta x, I have this equation, Vx initial multiplied by delta t. How did I get this? So remember we had Vx initial, which is equal to delta x divided by delta t. Okay, now I have Vx initial, which is equal to 30 multiplied by delta t. I don't have. How can I find delta t? I have delta y. Remember, we said that delta y is equal to negative 1 over 2 g delta t squared. This negative comes from the g. If you apply it later, if you use it later, it's fine too. So negative 200 meters, didn't know right meter, so negative 1 over 2 multiplied by 9.81 delta t squared. Okay, so negative 200 is equal to negative 4.9 delta t squared. Divide this by negative 4.9, divide this side too by negative 4.9. These two cancel. Delta t squared is equal to what? It is equal to 40.8. Take the square root of this. Okay, 40.8. Delta t is equal to 6.38 seconds. Okay, so this is what? This is delta t. Let's apply it in the equation. So delta x is equal to 30 multiplied by what? By 6.38. Delta x is equal to 191.4 meters. This is my delta x. Question B says find the velocity, magnitude and direction of the package just before it's dropped. Okay, so I have Vx initial, but it doesn't benefit me here because I need to find what? I need to find both components. Okay, now how can I find this? Be careful. Vy initial, guys, is equal to 0. Be careful. I need to find Vy final. What equation I can use? I can use this equation. V final squared is equal to V initial squared plus 2g delta y. Okay, why I should use this one? Because I have delta y, I have V initial, of course this is Vy, this is also Vy. Okay, yeah, Vy, and this one is Vy too. Okay, so this one is 0. I have V final squared, which is equal to what? It is equal to negative 2 before writing the negative. So I have 2 multiplied by negative 9.81. Then I have delta y, which is negative 200. Yeah. Okay, so let's multiply this. And 2 times 9.81 times 200. So I get V final squared is equal to 3,924. Take the square root, guys. Okay, so Vy final is equal to square root of 3,924. You get what? You get plus or minus 6.060 62.64 meter per second. So which one should I take? Of course I should take the negative, okay, because it's going down. So negative 62.64 meter per second. Okay, now the question says find the magnitude and the direction. Use Pythagorean theorem, guys. Okay, so V is equal to what? V is equal to Vy squared plus Vx squared. Vy squared is equal to what? Negative, of course this one is squared too, 62.64 plus Vx is equal to 30, so 30 squared. If you take the square root of this, okay, take the square root, this is equal to 69.45. So 69.45. This is what? This is the resultant vector. This is the magnitude. What about the direction, guys? So you know that theta is equal to tan inverse of Vy divided by Vx. Okay, so tan inverse of Vy was equal to what? It was equal to, let's see, Vy, yeah, 62.64. So divided by what? Divided by 30. Of course negative, be careful. Theta is equal to what? So negative 62.64 divided by 30, we get 2.088. Take the sign, the tan inverse, so you get 64.4, but be careful, negative 64.4, negative 64.4. So this is what? This is the direction too. These questions are a bit annoying, I can vouch for that, but if you have learned how to analyze a vector, what equations do we use for free fall equation, for free fall motion, and what equations do we use when you have an object that is thrown at an inclined place, this is going to be really easy, okay? In the next video, we're going to be talking about something really easy, which is relative velocity or relative motion. Until then, see you in the next video.